Good afternoon, everyone. I hope that you're having a great week so far and you're all doing well today. We're looking today at finishing up what we started on Monday when we dealt with function compositions or compositions of functions. On Monday, we learned what the composition of two functions involves, and what the composition of two functions involves is taking one function and using the entire function as an input in the second function. What we're going to be looking at today are different examples. This is on page 19 of your current lesson handout. And one of the differences between what we're doing today and what we were doing on Monday is now we're going to be dealing with at times three functions. You were asked to determine what k of x is if k of x is h of g of f of x. The first thing that you need to do is understand what this means. What it means is k of x is equal to h of g of f of x. What does that mean? Well, it means that we are going to take f of x and run it through g of x to get g of f of x. And then we are going to run that through h of x to get h of g of f of x. Another way that we can look at it, rather than using that diagram that I just drew, and this might be useful for some of you, is to say we need to take f of x and substitute it in to g. Then what we need to do is take the entire thing that comes out of that process and substitute it in to h. And then what we need to say is that whatever comes out of the whole thing is the answer to the problem. It's k of x. Either of these schematics or diagrams works. This is going to be a little bit more difficult than it would be if we were working with numbers. But let's start off by finding g of f of x. So I'm going to be looking here at determining this. Why am I determining it? Because that is the thing that I need to know to put into h to get my answer. So what is g of f of x? G of f of x is the result of taking f of x and putting it in for x in g, which means g of f of x will be equal to g of 3x minus 2. Now, g of x is an input squared minus 4. So g of 3x minus 2 will be 3x minus 2, quantity squared minus 4. Don't forget, when you square a binomial, what it means is you have to FOIL out that binomial. 3x times 3x is 9x squared. My outer will be 3x multiplied by negative 2. My inner will be the same result. And then I have negative 2 times negative 2, which is plus 4. Don't forget about this other minus 4 at the end of it. So what I end up with is 9x squared minus 12x. That is g of f of x. So what I have highlighted elsewhere here in yellow is what I have highlighted at the bottom. That's what has to now go in for x in h. There's a lot going on here. As soon as you go from two functions to three functions, it gets really difficult. So I know now that g of f of x is 9x squared minus 12x. That now has to go in for x in h. So k of x now will be h of 9x squared minus 12x. So k of x is h of 9x squared minus 12x. Now h is a function that takes an input and divides it by the input minus 2. And I'll just write the function h of x over here rather than scrolling up. H of x was x over x minus 2. Well, that means h is a function where the input is on the top by itself, and the input gets put on the bottom, and we subtract 2 from the input on the bottom. And we can remove those brackets now. Those brackets were there just for me to show you the substitution that's going on. I really want to drive home the fact that that 9x squared minus 12x is the input in h. This should be k of x. So k of x is equal to 9x squared minus 12x over 9x squared minus 12x minus 2. I don't know if that factors and simplifies. I don't think it does factor to simplify. But even if it does, that's not the point of this lesson. The point of this lesson is to get you thinking of compositions of more than 2 functions. This, in other words, everybody, is our answer. Let's take a look at B. We're dealing with the same functions, but now we want f of g of x. What does that mean? There are a couple of ways we can visualize what it means. One of them is to say that what we are going to do is take g of x, put it into g, then take whatever comes out, put it into f, and then say to ourselves, whatever comes out at the very end of this process is the answer. What comes out is f of g of x. The other way, of course, we can visualize it is to say that we are going to take g of x, put it through g of x to get g of x, and run that through f of x to get our answer, which is f of g of x. Of course, whether you're looking at the schematic on the left or the schematic at the top of the page doesn't change how you do the problem. G of x goes into g of x. So that means that we have to take, and this is a little bit wacky, let me write out what g of x is. G of x is x squared minus 4. We have to take x squared minus 4 and put it in for x in the function x squared minus 4. So g of x will be the input squared minus 4, but the input is x squared minus 4, so we end up with that expression. I'm not going to worry about foiling that out, because if we foil that out, we are going to get a degree 4 polynomial function. And that is not the point of what it is we are doing today. So when I put x squared minus 4, which is g of x, in for x in g of x, I get x squared minus 4 quantity squared minus 4. That now has to go into f. In other words, everyone, what we have just found, which I am going to highlight, is this. So to find the answer to the problem, we need to find f of that whole thing. What does that mean? It means that we're going to take that whole thing and put it in for x in f. F of x, when you take a look up here at the function f of x is tripling the input and subtracting 2. F of x is tripling the input and then subtracting 2. The input is x squared minus 4 quantity squared minus 4 because the input is g of x, and g of x was found by putting x squared minus 4 in for x in x squared minus 4. As I said, this is confusing with 3 functions. I would choose in this particular question to multiply that 3 through to get 3 times x squared minus 4 squared minus 12 and then minus 2, just because then I can bring the 2 and the 12 together and get my answer, k of x, which is f of g of x, is 3 times x squared minus 4 quantity squared minus 14. And as I said before, you can take that x squared minus 4 quantity squared and FOIL it out if you wanted to. I don't think we need to. That's not the purpose of this lesson. So this is our answer. K of x is 3 times x squared minus 4 quantity squared minus 14. All right, now things get a little bit easier because we're going to be dealing with numbers and not functions. Find each value. We have f of x, g of x, and h of x at the top, and we are asked to find f plus g plus h of x. This has nothing to do with compositions. We're going back here to sums of functions. What this means is f of negative 2 plus g of negative 2 plus h of negative 2. And my advice to you is when you have problems like this, don't try to do it all in one shot. Figure out what f of negative 2 is on the side. Figure out what g of negative 2 is on the side. And figure out what h of negative 2 is. We can add them together later. So I'm looking right now at f of x equals 3x plus 4. That means f of negative 2 is 3 times negative 2 plus 4. If g of x is x squared minus 9, then g of negative 2 is negative 2 squared minus 9. H of x is x over x plus 3, which means h of negative 2 is negative 2 over negative 2 plus 3. And we can calculate all 3 of these. It's not a big deal. F of negative 2 will end up giving you negative 6 plus 4, which is negative 2. G of negative 2, I have to square negative 2, which gives me 4, and then subtract 9. That will give me negative 5. And h of negative 2, I have negative 2 on the top. On the bottom, I have 1. Negative 2 over 1 is negative 2. So f of negative 2 happens to be negative 2, plus g of negative 2 is negative 5, plus h of negative 2 is negative 2. When we add these 3 things together, we get f plus g plus h of negative 2 is negative 9. That is our answer. All right, what about g of h over f plus g of 2? What this means is g of h of 2 over f of 2 plus g of 2. And we can figure out the top and the bottom separately. When we talk about the top we're talking about putting 2 through h and taking the result and putting it through g, and this will be the top. For the bottom, we have to figure out what f of 2 and g of 2 are equal to, because we have to add them together. This will be the bottom. I had mentioned in Monday's lesson somewhere, I don't remember exactly where, that particularly when you're dealing with numbers, you don't have to show a lot of work. So when I put 2 into h, here is h. When I put that 2 through h, I'm going to have 2 on the top and 2 plus 3 on the bottom. I'm going to get 2/5. That's what comes out of h. Now I have to put 2/5 in for g. So I'm going to use my calculator here. I'm going to take 2/5, square it, and then I'm going to subtract 9 and convert it to a fraction. And when I calculate the top, I get negative 221/25. So the top of this will be negative 221/25. The bottom, I have to figure out what f of 2 and g of 2 are. So for f of 2, I'm looking at f of x and putting 2 in for x. F of 2 will be equal to 3 times 2 plus 4, which gives me 10. G of 2, I now have to look at g of x. G of 2 is equal to 2 squared minus 9. 2 squared is 4, minus 9 is negative 5. So when we add those together, we get 5 on the bottom. And now we can figure out what negative 221/25 divided by 5 is. In fractional form, it's negative 221/125. And that is our answer. All right, C says we want to find g of f of h of 3. This means that you're going to take 3 and run it through h to get h of 3. You're going to take h of 3 and run it through f to get f of h of 3. Then you're going to take that number and run it through g to get your answer, which is g of f of h of 3. So what do we get for h of 3? H of 3, the result of putting 3 through h, will be the input over the input plus 3. H of x is x over x plus 3. So we have 3 over 3 plus 3, which is 3 over 6, which is 1/2. H of 3 is 1/2. Now we have to put 1/2 in to f. We are going to have f of 1/2. F of x is 3 times the input plus 4. So we need to figure out what this is equal to. I believe it's 11/2. Before I go any further, I should just check to make sure that that's correct. I'm pretty sure it is, but better safe than sorry. And it is. It's 11/2. Now what I need to do is take 11/2 and put it into g. So what is g of 11/2? Well, whatever it is, that's our answer. G is an input squared, so we have to take 11/2 and we have to square it, and then we're going to subtract 9. And we get 85/4. That's our answer. what comes out of this whole process is g of f of h of 3 gives us 85/4. F of g over h times g of -1 means f of g of -1 over h of -1 multiplied by g of -1. So you have three things to figure out here. You have to figure out the top, which is f of g of -1, which means we put -1 through g, take the answer and put it through f to get the top. Let's do that. Put -1 through g. G of -1 is equal to -1 squared minus 9, which will equal 1 minus 9, which is -8. Now we have to put it through f. F of -8. Well, f of x is 3x plus 4, so we have 3 times -8 plus 4. That works out to -20. So the top of this expression is -20. The bottom of the expression, we need to figure out what h of -1 is. H of -1 will be -1 over -1 plus 3. I'm looking at this function, which works out to -1/2. G of -1. Now I'm looking at this function. We already figured out what g of -1 was. We did that over here. It's -8. On the bottom, I have -1/2 multiplied by -8, which is +4. So I get -20/4, which is -5. And this is our answer to this question. Now we have one more thing left, and this is more difficult. It's still working with numbers, but you're going to be working backwards. Forget about what the functions are just for a second. Look at what the question says. It says find the value of a if g of f of a is 98. What that means is that a goes through f, some number comes out of f. When that number that comes out goes through g, 98 comes out of g. So we have to work backwards. We have to say to ourselves, if 98 comes out of g, what went into g? Well, g is x squared minus 2. So x squared minus 2 produced 98 when some number went in. So we're going to figure out what that number that went in would be. I'm going to add 2 to both sides and get x squared equals 100. And now I can take the square root and I can say it's equal to plus or minus root 100, which is plus or minus 10. And I want to put a condition on here, everybody, that x must be positive in all of these questions. And the reason I'm going to do that is there is a logarithm of x in the question. So we can ignore the negative and say x must be 10. That means that 10 went into g. And you can check this right now, because this part right here says when you put 10 into g, 98 comes out. Well, let's see. G of 10 is 10 squared minus 2. Yep, that's 98. The first part of our diagram now says that some number goes into f and 10 comes out. Well, 2x plus 4 is what the function f is. If that's going to give us 10, then we can certainly figure out the number that would have to go in to f to produce 10. It's a very trivial equation to solve in terms of your skills. Subtract 4 from both sides, and then divide both sides by 2, which means that the answer is 3 went into the whole thing. And again, you can check that. If I put 3 through F, do I get 10? Well, we put 3 up here. 2 times 3 plus 4 is 10. If I put 10 through G, do I get 98? Yeah, we already checked that. So the answer is A is 3. This is our answer. All right, 3b, j of h of a equals 0. What this means is that a, some number, we don't know what it is, that's the mystery. Some number goes into h. Whatever comes out, which is h of a, goes into j. And we know what comes out is 0 because we're told j of h of a is 0. So what this is saying is in the function j, which is log base 3 of x, what came out was 0. We have to decide what went in, which is the x-coordinate. Well, I'm just going to rewrite this in exponential form. 3 to the 0 equals x. 3 to the 0 is 1. That means that 1 went in. And again, you could check this by putting 1 in for x and seeing if you get 0. And you do get 0 coming out because log base 3 of 1 is the exponent to which you raise 3 to get 1, and that's 0. The next step is to say that some number went into h and the number 1 came out. Now what we can do is we can write this function, sine of x, which is h, equal to 1, and figure out what x can be. Well, now we're solving a trigonometric equation. Sine of x equals 1. On the unit circle, sine of x is equal to 1 at the top, which is pi over 2. So a is equal to pi over 2 rads, or if you wanted to work in degrees, 90 degrees. But we could put plus multiples of 2 pi because if I add 2 pi to that, I still end up at the top. And if I take away 2 pi from pi over 2, I still end up at the top. So this is our answer. And I'm sorry about that you thought maybe you were done with logarithms and you were done with trigonometry. We're not done the course yet, so you're still expected to understand some basics of them. The final example today. What is a if k of j of a gives you 8? So this mystery number goes into j. Something comes out, which is j of that mystery number, but it goes through k, and what comes out is the number 8. That means that since k is 2 to the x, we have to figure out what value of x goes into 2 to the x to give you 8. Well, this is a fairly basic exponential equation to solve. You can write them both with a base 2 and see that x is 3. 2 to the 3 gives you 8. Now we have to look at j, and j is log base 3 of x. That means that log base 3 of x spits out this output of 3. Some number goes into j and produces 3 for an output. Well, we just write this in exponential form and write 3 to the 3 equals x, and we get 27. So the answer to this question is that a is 27. And you can certainly check that. If you put 27 through j, you will have log base 3 of 27, which is the exponent to which you raise 3 to get 27, and that is 3. So 3 comes out of j. If you put 3 into k, here's k, we will have 2 raised to the 3. What comes out of that is 8, and that's what we were told is supposed to come out of this. The stuff we're doing today is pretty difficult because you're either working backwards or you're working with more than 2 functions or you're working with operations and compositions at the same time. But if you go back to the basics and do the pieces separately, you should be fine for all of these. Your assignment on the following pages, 3, 5, 6, 7, 8, 10, 12, and 19. Any other questions are optional. You can probably still do them, but it's up to you whether you want to do them or not. So I hope that made sense. Have a great rest of the day, and we will talk to you soon. Take care.